Thank you all for attending today's talk. My name's Angela Chin. Some of you might have seen me up here before. I'm a software engineer at Pivotal.
My name is Gaetano Borgione. I'm a network architect for PKS.
And today we'll be talking to you about PKS networking with NSX-T. Basically, how the story is, you focus on your app and we'll take care of the rest. So just a brief agenda of what we're going to talk about today. We'll start with a primer on what PKS is. Might be familiar if you were here at the last session, but I promise it's a little bit different. Before looking at what networking and Kubernetes at its baseline is. From there, we'll look at what NSX is and really the value add of using NSX with PKS and all the benefits that you get provided to you out of the box. Before then looking at how NSX and PKS work for both cluster creation and cluster upgrades. So we just have, again, a brief disclaimer. And with that, we'll get started. So what is PKS, right? So PKS stands for Pivotal Container Services, and it's a managed Kubernetes for multiple clusters. So this statement, I really want to call out two parts, right? First, that it's a managed Kubernetes. So it's not just that you're kicking the tires on Kubernetes. There's all these configuration options. It's a lot of different things that you can set up. You might want to set up, you might not. Kubernetes out of the box or Kubernetes without any guidance can be really overwhelming, right? And so PKS really looks at providing a managed Kubernetes experience. So we have engineers looking at sort of the latest features of each Kubernetes release, what things users and operators may want to be able to configure, and really try to give you sane, sensible defaults for your managed Kubernetes clusters. And we do it, secondly, for multiple clusters. So you don't have to have one PKS for each cluster. You can have one PKS installation, and it can be managing a multitude of different clusters for a multitude of different use cases. And we see here that PKS is really aimed at day 2 operations. So again, you have this managed Kubernetes, you're sort of getting these sane, sensible defaults with the options to configure it in different ways if you so choose for multiple clusters. And these multiple clusters are expected to be long-lived. They're expected to be able to run production workloads, and they're expected to have upgrades with little to no downtime, right? And so the way we do that is we use BOSH. So how exactly does PKS work, right? So you have your infrastructure, and then you have BOSH deployed when you deploy your ops manager. From there, BOSH will deploy PKS, PKS being a tile that you install in ops manager, and your PKS will deploy Kubernetes clusters, which BOSH will also watch. And you can create multiple different Kubernetes clusters that BOSH will ensure are long-lived, are healthy, and are able to run your workloads successfully. So, as we said, PKS deploys as a tile in Ops Manager. So we see the basic setup, right? A screen many of you are probably familiar with that we have, on GCP, your Pivotal Container Service as a tile. And once you deploy as a tile, we get your PKS up and running, right? And then from there, you can interact with this PKS via the PKS CLI. So the first thing you run probably is a PKS create cluster, which will then create your Kubernetes cluster. And then you'll run PKS get credentials cluster name, which will give you a kube config so that from there, you can interact directly with your Kubernetes cluster that's been created. Kube control get pods, maybe kube control apply some file, some spec. And so we see that it's really easy once you've deployed PKS to get a cluster up and running and usable. So now that we understand sort of how PKS works, you might be wondering, okay, so what is the state of networking in Kubernetes? So networking in Kubernetes really at its core is a choose your own adventure right now, because Kubernetes abides by the Container Network Interface, or CNI for short, which is a specification between third-party container runtime systems and networking providers for how they can interact with one another. So there's a variety of different networking solutions out there, a variety of different networking plugins, and because Kubernetes abides by the CNI specification, you can really choose your own as long as they provide an integration with Kubernetes. But by default, you'll see more often than not, if you're just kicking the tires, maybe deploying a baseline Kubernetes cluster, that you'll get flannel for pod communication. And so in addition to just getting a baseline flannel so that all of your pods are accessible, they all get their own unique IP, we also see that after you've set up your Kubernetes cluster, you also need to set up an ingress and load balancer more often than not, so that your workloads in your Kubernetes cluster can actually get traffic from outside of the cluster, right? So traffic coming into your Kubernetes cluster, ingress. And even beyond that, you probably don't want to let the whole wide world access your workloads in your cluster. So you want to set up network policies for enforcing network rules. What things can talk to my application? What ingress policies? What egress policies? What do I want my application to actually be able to talk to? And then also pod to pod. Do I want my pods in my Kubernetes cluster to actually be able to talk to and access one another? And so you'll see that network policy really is at its forefront, a key part of ensuring that your workloads are secure. But network policy is not provided by Flannel alone. Flannel focuses on connectivity. It doesn't focus on actual policy. And so we see right now that baseline networking, there's a lot of options to choose your own adventure, but sort of the default in the box solution that you'll see a lot of people use isn't really a feature-rich set. And so this is where NSX-T comes into play.
Thank you, Angela. You saw, guys, you need load balancers, pod connectivity, node connectivity, network policy for security. Where you are going to get all of these things? These things are coming from the NSX-T integration. We are using in PKS NSX-T as a platform to provide networking, security, and connectivity framework. At the same time, using NSX-T also to give you Day-2 operational tools to control and monitor and manage your clusters. How? With operational tools that are able to really perform debugging, troubleshooting, analysis of your traffic. NSX-T runs for a variety of platforms, different specific solutions available for PKS, PaaS in our specific cases. How does NSX-T add value to your open source solutions? Well, as I said, many of the networking components of your cluster are provided by NSX-T. So you don't need to worry about providing the surrounding environment. Your cluster is deployed, and all the networking requirements are satisfied by the NSX-T integration that PKS guarantee. Completely automation of dynamic provisioning on network object. It means that pretty much whatever your workload requires, from node networking to pod networking to service exposure, is done by NSX-T, integrating with the service events that Kubernetes exposed. We do provide a variety of options as well for the deployments of PKS clusters. When you deploy Kubernetes, in some environment, you want to have a globally routable access to your pods. In others, you want to just shield them behind the NAT. So both of them are deployment option, and with this click button on the PKS style, you can choose one or the other. Also, Angela mentioned, when you deploy a vanilla Kubernetes, you get the basic pod connectivity, for example, with infrastructural for communication like Flannel. But what about network policy? So when you configure network policy with Kubernetes, you require fundamentally some layer that through the CNI is able to implement or render the network policy in security construct. So NSX provides you this kind of layer of abstraction as well. You configure a network policy in Kubernetes, automatically the network policy gets translated in firewall rules that NSX distributed to your specific virtual network infrastructure. And the last but not least, as I was mentioning, tools, operational tools, not only to install and initially start with your cluster, but to operate with your cluster, to take care of the two operations that typically are fundamental when you're just not looking POC, but production level environment. On the operational tools, the majority of the value added by NSX-T is on the automation. So you can control fully the network capability with an open set of APIs, fully documented, available in terms of REST for the majority of the programming language available out there. Operations, you really have the ability to perform debugging, troubleshooting on networks, port mirroring, port spanning, export logs through integration with framework like Virialize Log Insight. And finally, troubleshooting. If you want to really debug end-to-end, pod-to-pod connectivity, trace packet, trace flows, all these specific tools are available out of the shelf from NSX-T infrastructure. So very easy in case you want to really perform a real-time analysis on a problem that your developers are experiencing on their communication pattern. Okay, so very brief introduction on NSX-T. How does the integration works? How does PKS make use of NSX-T to provide a better together solution? From a level architecture, PKS is based on BOSH. As Angela explained, BOSH is the orchestrator of the PKS solution. BOSH is the entity that deploys your Kubernetes clusters. Through BOSH, many nodes are deployed, master and workers, for as many clusters as you want, multiple clusters. Then NSX-T kicks in with providing connectivity between all these nodes, and also connectivity between nodes and BOSH. Fundamentally, one of the major ingredients is the on-demand broker. The on-demand broker is an implementation of Open Service Broker that provides a very open, standard, consumable set API for your services. And we do integrate NSX-T through the path that exists between the PKS intended to perform operation on the cluster and the broker itself. The component that is on the slide called NSX-T Proxy Broker is fundamentally the integrator entity for provisioning on node networking components. So, load balancer, firewalls, cluster connectivity. This is how a complex network topology will look like when you deploy a cluster in Kubernetes. Let me give you one example. You get access to a PKS environment, fully installed PKS, get exposure to the PKS CLI front end, then you start operating with PKS, create a cluster. When you do a PKS cluster create command, the result is that you not only create a cluster with all the nodes that the cluster requires, master and workers, but all the surrounding network components, the connectivity between the nodes, the connectivity between the pods, the load balancer that gets you access to the API server, it's automatically provisioned for you. You don't need to really go and manually provision or program any entity on NSX-T. It's all done through integrated framework. How we are getting there? Let me give a glimpse of the integration. When you really end up creating a cluster, you talk with the proxy broker. That is the entity I was just illustrated a few seconds ago. The proxy broker is an intelligent entity that, based on the intent of the operation you are performing on PKS, understand if there is any operation to be done on NSX-T to provision network resources. For example, when you create a Kubernetes cluster, you want to create a network for all the nodes, and so to be able for master and worker nodes to communicate with the BOSH director. So the proxy broker goes ahead, calls NSX-T through the REST set to API available on NSX-T, and provision the cluster nodes. Create a network, create a logical router, connect the logical router with edge routing, provision a subnet on it, associate the IP address to the individual worker nodes, and then, if you really program even NAT, create the NAT rules for you. All done by the proxy broker. Then, once the provisioning for the node network is completed, the proxy broker called the standard on-demand broker. And on-demand broker create, through the service adapter, the manifest for your new installation through BOSH. So BOSH now goes ahead and prepare worker and master nodes on a network that was set up by the proxy broker in the previous stage. See, fundamentally speaking, all the stage the proxy broker is doing for you in an automated way, you typically have to do in a manual way. That's what we integrate with NSX-T components. All the load balancer provisioning, all the firewall rules provisioning, all the NAT rules provisioning, all the creation of network, logical router, it's all done for you. Once BOSH is ready to go, BOSH is really playing basically with two releases. One is the CFCR release that contains the Kubernetes code, vanilla ones, to deploy for your clusters. And the other is a release that contains the bits that NSX-T uses for example, pod and node networking. So through the NSX-T bits that are controlling typically virtual networking operation using by Open vSwitch and the specific script that NSX-T deploy, the cluster is becoming alive. Master workers are deployed, and node workers are deployed as well. What is now important is that where are these nodes living? They are living on a virtual networking that is rendered by NSX-T. So NSX-T knows about these nodes, tag the nodes, and allow them to establish security between them. your Kubernetes cluster is not only deployed, but is secure, isolated. If you deploy multiple Kubernetes clusters, you don't need to worry about the traffic that from one cluster will go to different clusters. Because we isolate, we shield them out from a networking point of view. When your master nodes will be created, assuming you have a multi-master deployments, where you have more than one master, each one of the master nodes automatically will register with a load balancer, and will add itself as a member. So this means that when your load balancer is created, also your master nodes are added to it automatically. If a failure is detected and the master node is recreated, the member of the load balancer is automatically updated based on the new membership. So again, it's not just a creation, it's a life cycle of your cluster. If something needs to be done during the life of the cluster, if something goes bad, if some upgrade needs to really happen and the IP address change, we take care of it. So far we covered the NSX-T integration with Kubernetes when the cluster is created. But the integration doesn't stop at the layer. The integration goes ahead also when the cluster leaves. After you create a Kubernetes cluster, you create service on it. When you create a service, of course you want to expose the service to the external world. You want to be able, your developers, to access the service. Guess what? They also need the load balancer there. When you expose a service, typically you need to expose it to some form of methodology. Kubernetes makes available different options, or you deploy a layer 7 level using by ingress, or layer 4 using by service load balancer, or more fundamentally, the old node port methodology. So NSX-T integration takes care also of service exposure. There is a specific component called NCP, that is the NSX container plugin, that runs within Kubernetes. These components register and listen to the Kubernetes events that are important from a networking point of view. If you create a pod, if you create a namespace, if you expose a service, if you create a network policy, NCP will know about. Through the event registration that NCP performs, NCP then called the NSX Manager API to render that specific construct in networking construct. When you create a network policy, NCP create a firewall rules. When you create a pod, NCP create a container interface. When you create a namespace, NCP create a logical network, a logical switch, a logical router, connect to your edge router. So the full integration makes possible also at Kubernetes service level, a very deep integration with a framework that provide infrastructural support. So load balancer integration, we support both ingress and service or type of load balancer. When you expose a service, you get a load balancer allocated on NSX-T. And we take care of the dynamic population of your member pools. If your pods increase or decrease, the members on the individual load balancer virtual server will be updated accordingly. Namespace, let me give you one example. I mentioned that when you really create a namespace in Kubernetes, NSX-T give you a logical switch on the NSX-T side of things. How does it work? Assuming you really run your kubectl commands to create a new namespace, the NCP component intercepts the namespace creation event, and they will create a logical switch, a logical router. If you really have access to the NSX UI, you will see, as soon as you create a namespace, that the UI reflects the creation of these elements, logical switch and logical routing. If you go ahead and you create a different namespace, a new logical switch, a new logical router will be created on the NSX-T side as well. And once you create a namespace, you create services on it. So typically, as soon as you really instantiate a few containers to run on that new namespace, new pods will be created by Kubernetes, and NSX-T will automatically attach to the network and will create a firewall rule module for each one of the pod network interface. So they are secure from the moment they are created. And if multiple pods are created, they will all live on the same network for the same namespace. If the namespace run out of IP address because the subnet is constrained, a new specific namespace could be created as well. And then this methodology allows you to really scale the number of pods and the number of network as your load increase or decrease. This just to summarize what the integration provides you. Of course, since we are talking about the AT operation, we also take care of upgrade cycles. These NSX-T components not only are installed by PKS, but they can be also upgraded. And Angela will cover now few of the upgrade methodology for PKS.
Great. Thank you, Tom. So now that we've looked at sort of all the things that NSX provides to us via cluster creation and deploying services and deploying workloads, we'll now look at how exactly both PKS and NSX work in conjunction during a cluster upgrade. So honestly, we've said at the beginning that PKS is really focused on day-2 operations, having a smooth upgrade experience, so that there really isn't that much to cover with upgrades. What happens when you decide to upgrade PKS with NSX? Well, what you do first is you install the new tile, you update any new fields that may have arisen, new features, and then you click the Apply Changes button in Ops Manager. And your upgrade process, ideally, is smooth, and you get all the latest, greatest features of not only PKS, but of NSX, because as we saw earlier, PKS, or NSX is bundled in as a release in PKS. So similar to how Bosch will update everything for PKS, it will also upgrade everything for the NSX release. So if we think back to the diagram we looked at the very beginning of the presentation, we see that during an upgrade, what will happen is Bosch will first go and upgrade the PKS API deployment and all of its dependencies before upgrading each and every Kubernetes cluster. And so you get the, well, I'm not sure what happened there. So you get the upgrade of both the PKS API release, you get the upgrade of the NSX proxy that's packaged in, and you also get the upgrades of NCP within each of your Kubernetes clusters. And so, like we said, NCP components are upgraded within PKS. So if we focus in on a single Kubernetes cluster here, we see what happens during the upgrade process is that Bosch will first go and upgrade all of the master VMs, and then go and upgrade all of the workers. And even though NCP is running as a pod on the worker, we'll see that NCP will be upgraded with the latest, greatest new bits because it'll be upgraded as part of an errand run by Bosch. So we see that we get the upgrades there as well. In addition to getting all of the NSX-T upgrades while upgrading PKS that are bundled in, you can also upgrade your underlying NSX-T independent of PKS. They don't have to be upgraded in lockstep. So as long as the version of the PKS tile that you have deployed supports multiple versions, you can upgrade NSX-T independent. So for example, you might have a PKS tile that supports both NSX-T 2.1 and 2.2. And so you could upgrade from NSX 2.1 to 2.2 without having to worry about upgrading or doing any changes to your PKS tile. They're independent of one another. And with that, I think we've sort of covered it all. And thank you all so much.